Ciao friends! In this Unplugged video, I'm proud to show for the first time on the SQL BI channel DAX Optimizer. We have been working on this tool for many years. We launched the public beta a few months ago, and now we're close to the version 1, and so we are ready to show you the final user interface of this tool that helps you finding bottlenecks in your DAX code and provide a suggestion to improve the code and to improve the performance and the scalability of your solutions. So let's start with the demo. So before introducing DAX Optimizer, let's start saying what DAX Optimizer is about. The idea is that the service will help you finding bottlenecks in your DAX code even without executing any report. So before any user says the report is slow, we try to detect that there is an issue even before this happens. Of course, you can also use DAX Optimizer when there is a problem, but the best way to use DAX Optimizer is to avoid the problems to happen at all. And in order to see how DAX Optimizer works, we start from a very simple report where we have a small problem, and then we will see the entire flow of the actions that are required to optimize the report by using DAX Optimizer. So let's start with this Power BI report, which is a Power BI semantic model, where we have the data from Contoso, and you see a matrix here with a few measures. I don't want to enter too much into what is happening, because the idea is that we want to find the problem without knowing what the report is doing. And so we have a few measures here, and the thing I know is that when I start a performance analyzer and I try to execute this report, and this is also the experience of the user that opens the report the first time, we see that this report is not particularly fast. It is taking several seconds to be executed. And indeed, we spent almost 10 seconds the first time we executed the report. Of course, sometimes it is just the first execution, so we can try this again, but we will spend other 7, 8, 9 seconds. It depends on the conditions and the speed of the machine, but this is pretty much a consistent experience I'm getting. The number is always around 9 seconds, which we consider slow. We would like any report to run in less than 1, 2 seconds, and so we want to do something to optimize this report. Now, before starting, let's take a look at the model, because in this model we have the following tables. So it's a classic Contoso model where we have sales, several tables. The table sales itself is a table that has a couple of million rows, if I remember well. We can see that we have more than 2 million rows, and which in reality is not a big table for Power BI. What about the measures? If we take a look at the model, we have 151 measures in this model. Now, we're only using 2-3 measures in that report, and so if we want to optimize only that report, we should focus only on the measures in that report. But as we will see soon, DAX Optimizer actually analyzes the entire model, all the measures of the model, without knowing which report will use which measure. And so if we had to do the same, if we had to do an analysis of the model, we should analyze 151 measures. So this is the information we have. And so what is DAX Optimizer? So let's start to look at the user interface. When we enter DAX Optimizer, which is a web service, we have this welcome login action that is required. Now I enter with my work account, but you can also create a user with a username and password if you prefer. And once we enter DAX Optimizer, we have a user interface where we can create workspaces, areas of where we put our models and the information about our models. So let's start to create one. So I go in this test and I create a new model, and I create this model like let me start from this. So when I add the model, actually, what does it mean? Well, creating a model means creating a container that includes the information of the particular semantic model, in this case, my Contoso 1M that I want to test. You see that I already have a Contoso 1M here, but I will create a new one for this test. And once I create a model, I also have to provide the information about the model. But there is a problem. I have a PBX file. The PBX file in my local machine is something that is like 40, 50 megabytes large. So this is the size of my PBX file. You see that I'm going to analyze this model. The first version of this model is around 50 megabytes. And these 50 megabytes include not only the description of the model, but also the data that I don't want to share with anyone, especially a service in the cloud. So the thing is that we don't need the data. We don't want to provide the data, but we need information about the model. And how can we get this information? Well, we have a tool called Vertipack Analyzer, which is included in several external tools for Power BI. For example, if I use Bravo for Power BI is a simple tool that can be used to extract information about the statistics of the distribution of the data in your model. And Bravo uses this information to display this visualization that shows where we are spending the larger part of our memory and where we are consuming memory for the model. That is the first goal of Bravo. But in reality, Bravo has all the information also about all the columns, and this is useful to show this visualization. But the same information can be stored in a VPAX file. What does it mean? If I go to Demo DAX Optimizer and I store here my Contoso 1 VPAX, so I overwrite the existing file. The file that I created now is a file that contains the statistical information, how many rows in each table, how many unique values in each column, the name of the tables, the name of the columns, the name of the measures, the syntax, the DAX syntax of the measures, but no data at all. This format can be generated and can be read by other external tools. For example, if I open DAX Studio shows the same information with more details. It's a more technical tool that also provides information. Let's see here. If I go in Advanced View Matrix uses the same library to display the information about the state of the model. We can see how much memory is consumed by every column, every table, and we also have a summary of everything. The same information that we stored by Bravo can be stored with export metrics also by DAX Studio. Not only that, DAX Studio can actually read with import metrics, can read the VPAX file and show the same information that was saved somewhere else. And the advantage of using this VPAX file is that the VPAX file has only a fraction of the data. You see that we have only 44 kilobytes for this file. And do you want to inspect this file? Well, this file is a zip file. If I copy this file into, if I create a copy and rename this file into zip file, and this file can be extracted here, and this way I can see the exact content of the file, which is a list of files which are text files. For example, this is the file compatibility mode txt. Then we have the file DAX model JSON. Then we have DAX VPA view JSON. There is an XML file, and there is the bin file, which is the definition of the model. Now, you can inspect these files. They are JSON files, XML files, they are text files. They can be inspected, and you will find no data at all, no data from the rows of the table, just metadata, description of the table, columns, and measures. So this is important because now, when I go to the DAX Optimizer service, what I have to do, I have to send this VPAX file to the service. Before doing that, I create a workspace where I assign my a license of DAX Optimizer. DAX Optimizer is a commercial service, it's not free, so I need a license, and I have to assign the license to the model I want to analyze. And then with a drag and drop, I copy, so I show in the same window, I copy the file, the VPAX file, here. So these 43 kilobytes are sent to the service, and the service will analyze this file. Let's call this test SQL BI, and I upload the file. So this way, I have uploaded my file, and the service is now analyzing, actually is now verifying. It's just validating the file. It's just checking that there are no errors and the information are compatible with what we have in the service, because the VPAX file, the VPAX format changed over time, and so if you have a very old VPAX file, it could be not completely compatible, and so this is the initial check that is made. If you use the latest version of DAX Studio, Bravo, or Tabular Editor to extract the VPAX file, it will just work. Now that the check has been completed, you see that we can start the analysis of the model. And the analysis of the model, so without any additional information, just with the statistical information, this analysis will inspect the model. Now, what if you want to try the service? You can repeat the same steps I made so far, but you cannot send your model to the service. What you can do, you can enable, and actually the sample walkthrough is a set of sample files that is enabled by default when you connect to DAX Optimizer the first time, and you have a number of files that are also described in the documentation, where we can see the result of the processing of the first version of this PBX file that you can also download from the sample. So you can get the local copy of the file and see, inspect the very same file I'm using now and see the same description of the issues. So what happens at this point is that the engine figure out that in these 151 measures, there are 12 open issues. So the engine detected a few possible optimization for this model. And as you see, now we have actually 9 different issues types with a number of cases that is repeated. So the number 12 is the sum of the number of cases by the number of issues. And the important thing is that the sort order is made by using this column. What does it mean? What is happening is that there is an analysis of the model, there is analysis of the measures, and every time a measure has a behavior that could be optimized, there is an evaluation of the impact of this possible optimization toward the other measures and the entire model. This means that there are measures that could be very expensive but used only once, and another measure that could be less expensive by itself but is used so often that has a bigger impact over the entire data model. So the relevance that you see here is basically a metric that is a summarization. It's like a KPI that tells me how important it is to fix this measure compared to the other measures. Indeed, the actual value is 43 billion and 99 million, but only the first 6 digits are displayed, and this is the reason why the other numbers are so small. As soon as we will fix the top priority issues, the other will be represented with more digits, but we will see this later. Now, what does it mean that we have a problem here? So let's try to click on this element, where we see that there is an issue that is described with a title, SumX with if predicate on iterator column. So we have a case where this technique, we are iterating the sales table with an if statement, with a condition, usually is not a good idea. What does it mean? I should be able to obtain the same result by using other techniques. For example, the information that is provided shows possible ways to change the code to obtain the same result. So we see an example, another example, another example. Depending on the issue type, we could have more examples. Now, these examples are described using relatively simple code that you have to adapt to your use case. And you might have to make assumption about the ability to change the code in order to obtain the same result. Depending on what you will see in the description, this is possible, not possible. Maybe you have to do some assumption that the engine could not do. So the engine doesn't, let's say the engine of DAX Optimizer doesn't automatically change the code. That would be dangerous potentially, and hard to trust. But actually, it suggests you, first of all, where to focus your attention first, because that is the more expensive measure. And second, what to do in general terms. So you have to change the code from this way of writing the DAX to this other way. And usually there are several examples because there are several possible changes depending on the condition. And that's the idea. You have to be able to understand what is the right fit for your model, for your calculation. The engine will not be able to do this automatically with a complete with a complete confidence that the result will be the same, because actually it doesn't have the data. So we are providing suggestion without knowing what the data is and what the result of this calculation could be. So at this point, what happens? Well, we are looking at a number of suggestions, and the same issue type is actually present in another measure. You see that the refund amount has the same problem. But we can start to do some consideration. Why the very same issue with a very similar formula is so much more important for sales amount compared to refund amount? Because sales amount is used more often by other measures. Refund amount is probably not used much, whereas sales amount is used in many other measures, and so the impact of fixing this measure will be much, much bigger. So this is something I have to do where I have to go back to Power BI. I have to go to my definition of the sales amount measure, and I have to fix the code. Now, if I look at the proposal here, the code that is suggested basically moves the condition that is in the if statement as a filter condition in calculate surrounded by key filters, because this is the same semantics, potentially 95% of the time is the same semantic that we expect from this condition. So if I try to apply this change to my code, we are saying that we want to write calculate. In calculate, we invoke the same measure that was in the true condition of the if statement, and then we write in key filters the same condition we have in the if statement. Now, of course, in order to do that, one assumption is that, if you remember, there was a sum x of a measure. Now the sum x is no longer here, so we have to make the assumption that this measure is additive. If this measure was not additive, this would not have been possible. So how can we know whether this measure is additive or not? Well, of course, we could inspect the measure raw amount from Power BI Desktop, where we are now, or if I go back to the user interface of DAX Optimizer, I can see that I can navigate into the measures back and forth. So when I have a measure that invokes another measure, I can simply navigate through the call stack of the measures, and I can inspect, and in this case I can see this is actually an additive measure, so this is an assumption I can do. Now let's go back to, before moving forward, because now I confirm this measure in Power BI Desktop, I'm saying, well, I consider this measure fixed, which means that from now on I want this this issue to disappear from the list of things I have to do. Because now I'm using the sample that is provided in the free sample, when you create an account without having any subscription, this model is read-only. So now if I go back to the model that I uploaded before in Test SQL BI, if I navigate into the same issue with some X, now you see that fixed is something that I can check. So if I check fixed, what happens is that now this issue disappears. You can always show all the issues that have been fixed or ignored. We will see ignored later. But this way, when I go back also to this visualization, now we have only another very important issue to fix. And this other issue to fix is a very generic error, context transition executed with an iterator. And sometimes this is something we cannot fix. We will see later why this happens. In this particular case, I can show you the several examples, but we will see this later in another issue, if you want. But in this case, if I look at the code that I originally had, I already changed the code. And the issue that is reported here is that I have a measure invoked iterating a table. Now, if I look at the code in Power BI Desktop, in Power BI Desktop, I no longer have this case. So actually, the fix I made for one issue already fixed also the second issue. So what I have to do, also this issue has been fixed. I check this one, and now this disappears. Now, if I go back, you see that now the other issues appear with a higher relevance. But actually, the value of this KPI didn't change for real, because if you remember, the initial value was 49 billion, and this was causing auto scale of the number, and so we were looking just at the decimal part for the third and the fourth issue. But now that we no longer have issues with a larger relevance, what we have is a number that we can see. So now we could continue the process, continuing to optimize these measures. But wait a minute, we already fixed 2 measures. So let's see if our fix produced some good outcomes. So if I go back to Power BI Desktop and I confirm this measure, and I go back to my report, and I go to Optimize and Performance Analyzer, and I start a recording, and I refresh all the visuals. If you remember, we had more than 9 seconds in the first execution, and now the execution is 4 seconds only. So without having to understand and to read the query plan several times with DAX Studio, which is something that could take a while, remember, we immediately located the more important measure. We didn't know whether this measure was used or not, but because it was so important for the model, by fixing the first issue reported, we already improved the performance by 50%. Of course, you say, but you chose this use case intentionally. Clearly, this is something that I did, but believe me, we used DAX Optimizer for the last few years during the development, and in the real world, when you have hundreds or thousands of measures, it actually spots the more complex measures, usually in most of the reports in the first 10 or 20 position. That's it's very rare that you don't have in the top 10 something that is negatively affecting many reports. And of course, we are still running a report in 4 seconds, which is definitely too much for 2 million rows. So we still want to do something, but this was just to explain the process. Now, at this point, what can we do? Well, we can continue. So we can go back to our report of the problems, and we can take a look at the next higher at the next issue with a high ranking, which in this case is this other context transition in iterator. We have more than 40 different issue types, but you can imagine there are a few issue types that are very common and very easy to show without a deep explanation of the model and other details. And so this is something that you might see often also in your model. And in this case, again, I know that there are 2 measure references executed by iterating the sales table. We are executing the margin, and we're executing the conversion rate. Now, if you think for a moment, what is the purpose? So in order to understand what to do, usually you have to understand what the measure is doing. And this measure is iterating sales, computing a conversion rate from the USD, which is the currency that is used to store the transaction in the sales table, and the currency we want to use for the report. But if we want to report the values, for example, in Canadian dollar, Australian dollar, or pounds, then the currency exchange rate could be different for every transaction, maybe, or maybe no. Maybe the value of the currency exchange rate is the same for every day, or maybe for every month. How can we know that? This is the kind of analysis and assumption that you have to be able to do knowing the model. For example, if I look at the currency exchange table where we are extracting the currency exchange rate, we see that we have only the date column connected to date, and we have the exchange value and from currency to currency. We don't have any other information. And if we take a look at the currency exchange table, so if I go to currency exchange and I go in data and I sort by date, we can see that actually we have the currency exchange for every day. So you see that we have one row for every day. So we have to assume that the calculation, I mean, the way the code is written is actually every transaction in sales gets the corresponding exchange rate for the order date, if I remember well. Let me double check. The relationship is between, let's see, is between date and date. So we are actually using the date column here and the date column here. So that's it. So we have for every day we have the currency conversion rate. But remember, we had 2 million rows in sales, and we only have 2, 3, 4 years of data. Let's take a look at the currency exchange table. How many rows do we have here? Well, we have 200,000 rows, but we have only 8,000 dates, which means that given a combination of currencies, we expect to have no more than 8,000 dates. Now, 2 million, 8,000, there are 3 orders of magnitude. So if I can reduce the number of context transition by 3 orders of magnitude, I will improve my code a lot. So this is what I'm gonna do now is, okay, let's rewrite this code so that we can actually get some improvement. And how can I do that? So let's go back to, so this is margin currency. So let's start from margin currency. And we have this sales. So if you think for a moment, the calculation of the conversion rate will be the same for every date. And the margin can be aggregated for that day. And so there are no reasons to do this operation row by row in sales. I can simply group this sales table by date and by currency exchange from currency to currency. So what I can do at this point is that I can say, okay, I want to summarize sales by, we said date, sales date, sales order date, which is, yes, because the sales table, okay, so I'm checking that I want to make sure, okay, yes, because this is the date and date is this connection, whereas this one is order date. So if I group sales by order date, and actually I group sales also by date, which is probably better, once I have a date in the result of the table, I have something that is good to filter currency exchange. When I filter sales here, sales actually includes, with the context transition, includes date, includes currencies, includes everything. So when I have sales, I have one row which includes all the columns of all the tables in a many-to-one relationship, so including also date. But I don't need all these columns. I need only date in order to propagate the filter to currency exchange. So what I'm going to do, I'm going to change this code, summarize with date is the first thing. And then I have to probably also use the sales currency code, which is used here. So this is the other information. So now I have the date. The date will filter the conversion rate. I have currency code. And by filtering date and currency code, the margin will be computed only for aggregating all the rows in sales that have a particular combination of date and currency code. Well, it should work. So let me try this code now. And let's double check. Here we go. So now we have this calculation is working. So I still have to fix other measures. That's the reason I was looking at the performance, but the performance is still not good because I still have to fix other measures. But now I can say, well, margin currency is something that I fixed. And looking at the margin currency and sales currency, for some reason, the relevance of margin currency is bigger, but maybe it's not useful for the report that I was fixing now. So I fixed this measure, and I have to do something very similar for sales currency. So let's do this for sales currency. I can just copy this code because I know that the code will be very similar. So I go in sales currency, and sales currency can be fixed this way. I click OK. You see that already this is already 400 milliseconds, so it's already very, very good. And I can go back here, and this is fixed. Then total cost currency, so let's do the same for total cost currency. Go back here, sales, fix the code. And I think I also have refund amount. No, refund amount is something else. Let me check. Refund amount. Refund amount is the sum X that we have seen before. So this is something that I can also fix this way. So it's the same fix we made before. This one. And key filters. Now, when I go back to DAX Optimizer, I can mark this has been fixed, this has been fixed. So I fixed all the issues that were reporting context transition in iterator. And now you see that I have these other problems that I could fix if I want to move forward. But in reality, before moving forward, I can show the problems that I already fixed, because I wanted to show you that in the information of our context transition in iterator, we have several examples where one of the thing could be, one of the suggestions could be, move out the context transition if it is not required. So for example, if exchange rate does not depend on sales, you can move it out in a variable because it's not going to change. This is not our case because if you remember, we had a different exchange rate for every date. So this is another case where if we have the average, but it's not depending on sales, this would be another possible operation. This is just another possible optimization, which is similar to what we did. You see that in this case, we instead of iterating sales, we iterate sales order date because we know that exchange rate only changes for each order date. So this is also in the description of the issue and the example. That's the possible suggestion. And another one is the example 4 that could be another way to optimize the code. So again, you have to spend time looking at examples and figuring out whether the conditions and the assumption that you have to do in your model are compatible with the suggestion, and then try to validate also if the result is still the same, and of course if the performance improved. However, now that I fixed everything, what should I do? Well, let's say that now I want to save this file. So let's save this as a version 2 in DAX Optimizer. Okay. And I want to go to the external tool. Let's go this time in DAX Studio. And I want to save the VPAX file, the new VPAX file. So I open in advanced the view metrics. I export the metric. This is the V2. And I go back to DAX Optimizer. And you see that now I have a new version of the same model. So what can I do at this point? I simply can add a new version to the model that already exists. So I can keep track of all the versions of the model because I said to DAX Optimizer, I fixed this measure, but how can DAX Optimizer be sure that we did it? In the next release, if I declared an issue as fixed, it will be validated again, making sure that that issue is not present anymore. So I have to copy the file from here to here, continue. And while this validates the data, we can take a look at the sample walkthrough where I have a very similar approach. So what we did here, we saved several versions. I don't remember whether this is exactly the same list of issues. For example, in this case, we still have the initial issues that I shown you before, but if we go in the second case, we still have a few issues present. But as you see, in this case, we declared as issues that we wanted to ignore these ones. Let me show you why. Because if you remember, Now, the version 2 is the version that we sent now. And so at the beginning, when this file was processed, these fixed and ignored flags were not set. They were clear, so everything was visible, which is probably what I would expect now in my test SQL BI. So let's see if this test SQL BI is ready to be analyzed. So I start the analysis, and I see in a few seconds what happened. Okay, so the processing completed, and we have now 8 open issues. So it seems that something is still not good, and indeed, you see that the context transition in iterator is still here. Let's take a look. If you look at the code, this is the code that we modified, but we still a report that says that we have a measure and another measure, so we have 2 measures invoked in an iterator over a large table. Because even though we don't have 2 million rows, we still have all the combination of currency code and date that could be tens of thousands of unique values. But in this case, this represents what we need to do. So sometimes, especially this context transition iterator, but also other warning that we might receive, they could be a false positive. Report that something could be expensive, but actually is something that we have to do. This is one case where we simply want to ignore the problem because there is nothing we can do, and actually we want to pay the price for this calculation because this is what we need. So we ignore these 3 issues that actually were reported for 2 cases because, as you see, margin currency has 2 measures, 1 and 2, that report this problem. You see 1 and 2. And so you see that we can also highlight the single cases for a measure. And if we go back to the list of the issues, now these 3 issues have been ignored. We can also hide them, and we can take a look at the 2 remaining issues. In this case, we have a case where this syntax, if error, has been used, but in reality, if we take a look the code we have, instead of writing the code with if error, 2 measures with a division and 0 or another expression, we could have wrote divide. And we can apply these changes. So if I go back to the definition of the measure, so this was margin currency percentage and also margin percentage. These 2 measures have the same problem. So let's go to margin percentage and simply write divide margin, comma, because divide has 2 arguments, and the 3rd argument could be blank, or because the default is blank, I could just keep divide this way. So this was 1, and the other was a margin currency percentage, which is this measure. Same thing, so divide, comma, sales currency, and nothing else. In this case, the example was very, very close to the change that I had to make. Now, this change probably didn't have a big impact. Indeed, if you remember, the relevance of these cases was very small. So we fixed this one, and we fixed also the second one, and now we have everything that has been fixed. But of course, we still have to validate whether the fix has been successful or not, and indeed, in order to do that, we can upload the model again. So just to show you what happens when we update, when we upload the 3rd version of the visual, of the VPEX file for this model, we move from the version 2 to the version 3, where everything has been verified and everything has been optimized. Now, in this example, I wanted to show you the easiest way to go through the list. And one important element is that I didn't have to optimize all the measures. I probably can just optimize the first measures in the list. And what DAX Optimizer does, it improves the time. Let's say it makes my time more efficient because I spend time on the more impactful measure that I have to fix. In the long run, I probably want to fix everything, but in the short term, I want to optimize what provides the biggest benefits. Over all the reports, because this is important not just for the performance, but also for consuming a lower amount of RAM for our measure, because this way, with the same capacity, in Power BI, for example, you can have more users, more concurrent users, without requiring an increase in the capacity. How can you know whether a measure is expensive for the RAM or the CPU? Well, a visualization, if we go back to the version 1, we have the list of the issues that we have seen here, but we also have the list of the measures. And when we look at the list of the measures, we have all the measures of the model, not just the ones that have issues reported, but all the other ones. And I can actually display in the expert view more information about the measures so that I know whether a measure is more or less expensive compared to others. So let's go back to our test model, because here in the version 1 we can see the measures that are reported. Of course, now the visualization consider the issues that we declared as fixed. This is the reason why the relevance is so high now, because it has been recomputed with the new parameters. But what is important, I think, is looking at these values here. You see that the CPU cost could be very, very high, but for measures that have a low relevance. Whereas there are other very high values for relevance, so let's take a look here, where the CPU cost and the RAM cost is not that big. Why is it possible? Well, once again, you have to consider that every measure has a different number of possible execution. The sales amount measure could be executed up to 112 million of times because it is executed in iterators by multiple measures. Indeed, there are 3 direct references to sales amount, so there are 3 different measures that invoke sales amount, but there are 260 indirect references. So if you have a measure that invokes sales amount and the measure is invoked by another measure, this becomes an indirect reference to sales amount. So when you have a measure that are used by many other measures and this continues for several layers, the measures at the bottom of the calculation are those that have the largest number of indirect references. And if you remember, we said we have 151 measures, but we had 260 references here because it means that there are measures that invoke sales amount multiple times in an indirect way. What is CPU cost and RAM cost? Is the estimated cost in terms of RAM and CPU. This is not an absolute value, how much RAM or how many seconds. Is an index that tells us in a relative way how a measure consumes more or less memory compared to other measures. This is the thing you have to do is always to consider these numbers are relative numbers to create a comparison between different measures in the same model. This is important because this means that I can see whether a measure could be a problem for the performances or for the RAM or for both, oftentimes for both. But there could be measures that are slow in CPU but don't consume much RAM because, for example, they are executed in the formula engine only. Or there are measures that create large temporary tables and are slow also for that, but consume a lot of RAM. And this could be a problem, especially for the capacity, because you could go out of memory when you have too many users. So once you understand how to use DAX Optimizer, after you solved all the problems, you can also use these metrics to understand your model better and to focus on the possible bottlenecks of the problems that DAX Optimizer might not be able to solve. DAX Optimizer cannot find everything, right? It cannot find any kind of issue because sometimes the measure could have been written the right way from a formal perspective, but the optimization is in the algorithm that you can write. So even though you used all the best practices from a DAX syntax point of view, you might still have something that you can do at the data model level or in the calculation level, in the logic of the calculation that could be more efficient. The metrics here can help you to find the measures that are more expensive, that have more impact over the other measure, even though they don't have any issue. So when you see this green, it means that they don't have any issue reported. Whereas when you see the red flag, the red dot, it means that there could be some issue that could be used to improve the measure syntax. So this is a big overview of DAX Optimizer in terms of what is the complete walkthrough about the features for optimizing a model. Of course, DAX Optimizer is a commercial service. There are different type of licenses that you can find on the web page. There will be soon a launch of the version 1. And so it's better to always check the website to get the more updated version, the more updated information about the pricing and other details. What is important to understand is that what we have seen now is the single user experience. What if we have other people that we want to, other people that want to see the same information we see or that want to collaborate with us? Well, we have two different options at this point. One is that I could simply share my workspace. So I could invite other other DAX Optimizer users, also users that are not part of our organization, and show them the result of the analysis in read-only mode. So this share workspace feature is like I share in read-only the content of my workspace. Okay, this is the feature share. There is another feature that allows to share in read and write the models that we have in a workspace. So if I go in groups, I can create a group that will be made by a list of people that must be part of the same organization. So when you want to use the groups, you have to use the Microsoft Work account. You cannot use just username and password, and these users have to be part of the same tenant. This is also for security reasons. But at that point, the users can read automatically all the models in the same workspace and can also run new analysis. So this means that with a single license assigned to the group, you can have an entire team that uses the features of DAX Optimizer. And this is also a way to optimize the use of the license so that several users can share the same license. This is already possible with the current licenses that are provided by DAX Optimizer. So I think that this completes this first overview of this tool. DAX Optimizer is a tool that I personally where I personally participated in the creation and the writing, at least of the initial part. In the last few years, other people contributed writing the code to implement the service. At the beginning, Daniel Oettinger, who is the author of Tabular Editor, and I spent time studying whether this was possible or not, because remember, what we do is a static analysis of the model without running the code, without using the data, and this tool actually works well finding the more common issues and prioritizing the effort in spending the time to fix the code. It could be a very helpful tool to improve the code, to improve the readability of your code, because it also suggests better ways to write the DAX code, even when it is not necessarily tied to performance optimization. And in the long run, of course, we hope to be able to add other features to DAX Optimizer. In this first feature, in this first release, we have the analysis of the measures only. We don't have an analysis of the calculation items and of the role-based security filters. We don't have also the calculate tables and the calculate columns, but those elements usually don't contribute to problems at the query time. We want to focus at the beginning just on the performance at query time. And so we will do something for calculation groups and security filters. In the documentation, you will find there are workarounds to test using specific measures the behavior of a calculation item or of the security filter. So, but these are features that will probably arrive in future versions of the tool. I hope that you will try DAX Optimizer, give us the feedback about the tool, what you think, what you would like to see in future versions, and as usual, enjoy DAX.